Okay, hi everyone. This is a lesson to go over, or sorry, a video to go over 4.5 on curve sketching. This is almost a little review lesson, so we're not really learning any new skills today. We're just putting together what we've done in the last few lessons in order to sketch a curve using calculus. So we're going to be doing actually two examples that we saw last lesson. So I'm not going to be doing a lot more work. I'm going to be going back and pulling the derivatives from those. So if you need to go back and see more detail about these functions we're going to be looking at today, then you can go back to the 4.3 videos. Okay, so our goal today is to, given a function, if we have no idea what it looks like, how can we use the first and second derivatives and the tests we were looking at last day, those tables we were making, how can we turn that into like an actual sketch of the graph that's accurate? So let's look at this first example. So this was the same polynomial we saw last time, 1 over 4x to the power 4 minus x cubed, and we did the first derivative test and the second derivative test already. So I'm just going to go and pull those. Okay, again, if you need to see how to do those, just go back to the last video. Okay, and I sort of wrote them nicely side by side so we can have them here. Okay, so like I said, note that we already completed the first and second derivative test in the last lesson. So we did the first derivative, we found our critical numbers, then we did the first derivative test, and then we did the second derivative, found our critical numbers, did the second derivative test. So how can we turn this into an actual graph? So what you do at this point is you need to make sure you've labeled all your points correctly. So we've got, or we've made the right conclusions, right? So we've got where the function's decreasing and increasing. We found the local min here at x equals 3. We found our two inflection points at 0 and 2, and we've got where the graph is concave up and concave down. Okay, so that's step one, is to do those tests. So I'm not going to do them again. Now you need to make a table of values, and you got to choose numbers that make sense for your graph and include all of these important points that we were looking at here. So our sort of main points that we need to have on our graph are 0, 2, and 3. So I'll just pick X. I'll start at -2. 0, 1, 2, 3. Sometimes you need to do half points as well to get like a good accurate. It just depends on the graph. Okay, more points doesn't hurt, right? Add more if you need to. So now you're just going to plug these values into the function. I know it's a bit tedious, but I'm only going to have you do like 1 or 2 of these on a test, so it's not that bad. So you need to plug them into the original function, right? Because we're plotting the original function. And you can just believe me, or you can plug it in yourself. But I found these ahead of time. So when I plug in -2, I get 12. I get 1.25. When I plug in -1, 0, -0.75, -4, -6.75, 0, and 31.25. At some point, most of these functions are going to increase quite rapidly and kind of jump off the graph. So that's already going to be off of the graph. Okay, once you make your table of values, it's a good idea just to kind of write beside the table like our important points we need to remember. So remember that 0 and 2 were inflection points, and 3 was a minimum. We don't know whether it's a local minimum or a global minimum. We got to graph it to find out. Looks like it's going to be global though, because I don't see anything less than -6.575 on there. Okay, now the next point is just plotting like you would have learned many years ago. So -2, 12, -1, just be as accurate as possible. 0, 0, that's an inflection point. 1, -0.75. Careful of the scale here too, right? This is going, the y-axis is going up by 2s. So actually this one is not that accurate. I need to make that better. There we go. 2, -4, 3, -6.75, 4 is 0, and 5 is way off the charts. Okay, so before you did calculus, you have these points, but then you don't really know the shape to connect them with, right? So that's what the concavity is going to help us with. It's going to tell us where we sort of make a U shape and where we need to make sort of an M shape. Happy face versus sad face, right? So in the first region, let's just look. The first region here, but less than 0, we're going to be concave up. So my graph should sort of have this U shape to it. So when you connect your points, make sure you have that nice shape, right? And then concave down between 0 and 2. So I want to have sort of that sad face shape. If you need to plot a few more points to help, you can do that, but from the concavity, you can tell the shape. And then in this region for greater than 2, we're concave up again, so a U shape, and it's going to be pretty sharp. Okay, I'm using color. You don't need to use color, but let's just redo that. Sometimes you definitely should use a pencil the first few times you do this because you're going to need practice drawing these, because I'm looking for accuracy here. So I'm just going to connect it now with my pen. My hand's shaky because I've had coffee. Okay, how good can I do this? There we go. Well, it's not that bad, actually. It's helpful to draw the yellow and blue first. Okay, so I would say that's a great graph. The last thing you need to do is label the important points on the graph. Okay, so we had 3. We had inflection points at 0, 0. We had an inflection point here. You can do IP for short. To -4. And this point from the graph, now we can tell if it's a global minimum or a local minimum. From the derivative test, you can't tell whether it's global or local. But now we can tell it is a global minimum at -3, -6.75. Okay, so you need to make those labels at the end because I need to know that you can interpret those points. Okay, so that's the sketch. Okay, so let's just review. Do the first derivative and the first derivative test. Second derivative test. Make a table of values. Okay, definitely include your key points on there. Sketch the, sort of plot the points. And then from the concavity, you can tell the shape of the graph. And then you want to label at the very end. Okay. So we'll do one more example. This one is going to look a little bit different. This is that tricky one we did last day with the fractional exponent in there. So again, I'm going to go back and just grab the first and second derivatives because we already did them last time. Oh, if you guys don't know about the snipping tool, by the way, you should definitely use it. So it's just an application, I guess, that's built into Windows. And it lets you take little snips. But the other cool thing you can do is, oops, if you snip like a piece of writing or something that you didn't mean to, you can just like white it out with a pen. And so it makes your, yeah, it's really nice. And then you just press Control-C to copy it. And then you can go back to wherever you want it. So this is what I do when I email you guys and I draw fancy pictures. I use that little snipping tool. Okay, cool. So again, I'm not going to go over the first and second derivatives because we spent a lot of time in the last video doing those. So I'm just going to go straight to the plotting of points, right? Because that's what we're going over today. So let's just review what we've got here. So this function has both a minimum and a maximum point. I'll just highlight them in red. So x equals 0 is a maximum. X equals 2 is a minimum from the first derivative test. And then we had only one inflection point here at x equals -1. So definitely in my table, I need to include those 3 points, but I'll definitely include more as well. So let's just make it as long as I can. Okay. And again, you can either plug it in using a calculator yourself or just believe me. So I'll start at -2 again. 1, 0, 1, 2, 3, 4, 5, 6. Oops. I kind of know when to stop plugging in points by looking at the grid here that I've given you. So you should sort of use the X values from the grid, because after those ones, it's going to probably go off of the screen. That's why I've picked that particular size grid to provide. So if you plug in -2, it's -11.11. And this is -6. 0 is 0. 1 is -4. 2 is -4.76. 3 is -4.16. Again, I know it's tedious, but has to be done. 6 is 3.3. Okay, so now it's time to plot the points. Before I plot, I'm just going to remind myself of my key points here so I get them right. So 0 was my maximum. It's either local or global, no, not sure. X equals 2 was a minimum. And then I had one inflection point at -1. Okay, so -2, -11. So it's about there. Okay, -1 is -6. Here we go. Okay, 0, 0, 1, -4. 2, -4.76. 3, -4.1. 4, -2.52. 5 was 0. And 6 was 3.3. Okay, so let's have a look at the shape after you plug in the points. So I'm concave down for x less than -1, and then I'm concave up everywhere else. Okay. Also, what's important here is I have an undefined first derivative and second derivative at x equals 0. If your derivative is undefined, but the function is, so I'll just write this down. But the function's actually defined at that point. It's equal to 0. That means it must be a corner. Right? Or, I guess, or vertical slope of tangent, vertical tangent. Okay, so we'll be able to tell whether it's a corner or vertical tangent when we sketch here. Okay, so concave down for x less than -1. So I'm going to have kind of a sad shape. Okay, it's pretty steep though. And then I'm concave up for the rest of it. So concave up and then smiley face, concave up. It's hard to tell in this region here less than 0 because it's so steep, but you can kind of do your best. Look naturally here, we can see it's a corner. It can't be a vertical tangent line. If it kept increasing after 0, then it would be a vertical tangent, but in this case, it's pretty obvious. Okay, so we'll do our best to connect the points. I kind of do 1 or 2 at a time, just because my hands are extra shaky. My coffee. Okay, there we go. Perfect. Last step, always label your points and we can tell whether they're absolute or local minimums or maximums. So here is my inflection point at -1, -6. I've got, so this is not a global maximum at 0 here because you can see the graph on the right hand side keeps increasing. So this is just a local max at 0, 0, and I have a local min at 2, -4.76. Okay, and that's it. So it was just a little bit of a review today of the first and second derivative tests, and then we're basically just plotting points and using the derivative test to give us the shape of the graph. Okay, so we have a different type of assignment today. There's just an attached worksheet, and it's more of a review of 4.3 and 4.5. And so you'll be just reviewing the concepts from both of those sections in that assignment. Okay, that's the end of the lesson.